Okay, calculus, this is our last unit. We have made it to the last unit of the year. This worksheet is available on Schoology, so you can either print it and do all your notes by hand if you have access to a printer. If you do not, you can just use this in Notability. You can split screen. We're going to take notes on half of it, and then you're going to finish the other half and submit it. So I'm going to do half of the work with you on this couple page worksheet. So let's go ahead and get started. So we're going to start by finding the area of the region that is bounded by the information given. So it is a line of x plus 3 and the vertical line of x equals 4 and a horizontal line of y equals 0, which is the x-axis. So anytime you see y equals 0, you're talking about the x-axis. So I'm going to zoom in here. We're going to draw or darken the x-axis, so I know I'm looking at that line right there. I know I'm looking at x equals 4. And I know that I'm looking at a line that crosses the x-axis at 3 and continues to do a rise over run of 1. And so there is my line. It continues down here. So I end up getting this triangle shape that is formed. So this is the region we're talking about that I would like to find the area of, as asked in the question, to find the area of the region. Well, what are the limits of integration? Your limits of integration are the bounds that we're using. So we have to know where does it start over on the x-axis and where does it end on the x-axis. This is not new. Well, to figure out where it ends up on the x-axis over here, this is the line x equals 4. So we're pretty confident it crosses, or it ends at 4. But where is it over here? So you can continue doing like your rise over run until you land here on the x-axis. That's fine. Or you can take your equation of x plus 3 and set it equal to 0, and you'll see that it equals -3. So it's just setting it equal to 0. So I'm going to go from -3 to +4 of x plus 3 dx. Well, how do you know that those are the limits of integration? I know that those are the limits of integration because they're what bounded inside of that region. They are the starting point and the stopping point. So it's where it starts on the right and ends, that's silly, starts on the left and ends on the right. Okay. Set up the integral and solve it by hand. So this is us finding the antiderivative of our integral. So the antiderivative of that would be 1/2 x squared plus 3x. It would have a plus c, but we're going to integrate it from -3 to +4. I use that vertical line to say you're doing this, here are your bounds. So now I have to plug in a 4. So that's 1/2 times 16 plus 12. You could technically do a plus c, but that plus c is going to cancel out with the other one because you're going to subtract. If you put in a -3 here, you end up with 1/2 times 9, and then it'll be -9 because that's -3 times a +3. Okay, so all in all, again, I'm doing this by hand, so that's going to be 8 plus 12 is 20. The second one is going to be half of 9 minus 9, so that's -4.5, but I'm adding, it'll be minus -4.5. I'm going to write it all out just so you can see what's happening. So that means plus, so it's 24.5. Okay, now verify by doing that on your calculator. So -3 to +4, this is what you would type into your calculator. You know how to do that part, and we should end up with 24.5. Now that's saying that the area of this space is 24.5 square units. Okay, so you're going to have one more of those to try on your own. I'm not going to do this one with you. You are doing this on your own. And that is part of your submission today. Okay, the second page, these are talking about what if we have two functions that intersect. That means they have the same x and y values at their ordered pair. That's algebra 1. It's just saying if I have these two lines that cross at a certain spot, that they share an x and a y at that spot. Okay, So how do we do that? Well, we can actually set them equal to each other. That's called equating. Okay, setting them equal to each other, equating the equations, making them equal, finding out where they're equal to each other. Now, in this case, we found the x values. You could also then substitute that back in and find the y values. So this was just setting this x squared plus 4 equal to the 7x minus 8. And then this one involved moving all the terms over where it equaled 0 and then using a factoring technique. Okay? This is all Algebra 1 here. The second example that is done for you just involved some fractions. So just a different, still equating. We're still setting them equal to each other. We still move everything over from one side to the other. It still equals 0. Now from here you could have chosen to take the square root, which is what is shown, or you could have done x minus 2x plus 2 and gotten the two different values as well. Okay, so either one of those. So it intersects at two different places. Okay, so these 4 examples right here are what you're going to do on your own by finding out where they intersect. There are graphing features here, but I'm looking for you to do it in an algebraic manner. So your options are, after you set equal to each other, so the first step would be to equate them. Okay, make them equal. The second step would make all this stuff equal 0. And then now you have choices. You can do the square root method, which was like example number 2. And that only works when you have like x squared minus a number equals 0. You can't have any other terms. You can't have like a 4x in there because you can't take the square root of that. The other option would be to factor, which you saw in example 1, or you could use the quadratic formula, of which I'll remind you what it is. The opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So you got 4 problems to try right here, along with graphing this number 2 up here and then following through with by hand and verifying it on your calculator. So I'm leaving you with that. You can, again, do this on paper if you want to. You don't even have to print the worksheet. Somehow I want to see number 2 drawn out, okay, sketched up, and then these 4 problems. However you do them on Notability, on paper, and take pictures, just send it to me on Schoology. You guys have a great rest of your day, and I miss you very much.